Hello, good morning viewers. Welcome to KU Band live lecture on earthwork calculations. Today in this session we shall discuss about the following topics in earthwork calculations. In earthwork calculations we shall discuss now about the introduction to earthwork, formation level of a road for plain country, formation level of a road for hilly country, the cross section of a road in cutting, the cross section of a road in banking, earthwork in canals, calculation of area of cross section of a canal or a road, and the methods for calculation of quantity of earthwork. Now, let us discuss about these topics each one by one now. Almost all civil engineering projects involves the earthwork, that is either for example roads, railways, canals, earthen dams, tank bunds, etc. Either the earthwork in excavation or in filling, both are used for forming a level. Here the earthwork in filling is commonly referred to as earthwork in embankment. When we use the term earthwork in embankment, it is nothing but the earthwork in filling. Next, the earthwork in excavation. The earthwork in excavation is commonly referred to as earthwork in cutting. When we say that the earthwork in cutting, that is nothing but the earthwork in excavation. Basically, the earthwork is computed from length, breadth and depth of excavation or filling. That is, for any civil engineering project, it is necessary to know what is the level of ground or where is the formation level. Now, let us see the formation level of a road or a ground. This visual shows the formation level of ground. This is the curved line is the reduced level of the ground. This portion is filling, earth in filling, and this is the earth in cutting. Again filling, cutting. Practically when we see the earth is not, the level of the ground is not horizontal, not plane. It is always undulations, it is having some undulations. This is the general formation level of a ground. This is the reduced level of a ground. Now, let us see the formation level of a road for plain countries. For a plain country, this is the ground level which is horizontal. And this is the formation level, that is the formation level is considered to be as plane in case of plain countries, that is it is a level, there is no cross slope. This formation level is fixed considering the flood level, height of bank, depth of cutting, gradients, etc. So, generally when we take for a plain country, the ground is considered or assumed to be a level surface. Similarly, the formation level is also a level surface. Now, let us see the formation level of a road for a hilly country. For a hilly countries, the road may be, that is the topography of the ground may be either sloping downwards or it may be sloping upwards. Generally, in case of hilly countries, the nature of the ground may be either in banking or in cutting. So, the quantity of earthwork which is there, which we excavate from the excavation, that is from cutting, we use that earthwork for banking purpose within the economical limits for the construction of the project. Now, here we can see the formation level of a road in case of hilly countries which is sloping downwards. And here we can visualize here the formation level of a road sloping upwards in case of the hilly countries. this is how the formation line is fixed. Now, let us see the cross section of a road in cutting. Here we can visualize the cross section of a road in cutting. The cross section of earthwork of a road in cutting or in banking is in the form of a trapezium. Here we can visualize this is the ground level and this is the top width or width of the road in cutting. N:1 are the side slopes of the road in cutting. Let B be the depth of the road in cutting and D is the depth of cutting and B is the breadth of road in cutting. This is the cross section of a road in cutting. Now, let us visualize the cross section of a road in banking. Here we can visualize the cross section of a road in banking. The cross section of a road in cutting or in banking is in the form of a trapezium. This is the ground level and this is the cross section of a road in banking, where B is the top width of the road in banking and D is the depth of the road level above the ground surface, and N:1 are the side slopes of the cross section of a road in banking. Now, let us see how to calculate the quantity of earthwork for the cross section of a road in cutting or in banking. The quantity or volume is nothing but the sectional area multiplied by the length. What is the sectional area? The sectional area of a trapezium, because the cross section of a road in cutting or in banking is in the form of a trapezium. It is the sectional area. The sectional area is nothing but the area of central rectangular portion plus the area of side triangular portions. As we have seen just now about the form of cross section of a road in cutting or in banking, it is a trapezium, the central rectangular portion plus the area of side triangular portions. So, the area of rectangle is breadth multiplied by the depth plus there are two triangles in a trapezium. So, 2 into area of a triangle is half into base into height, that is where D is a depth, that is equal to BD plus N into D square. This is how the sectional area of the road cross section of a road in cutting or in banking is calculated. So, how to calculate the quantity or volume of earthwork? The quantity or volume is nothing but the sectional area multiplied by the length of the section. Sectional area multiplied by the length will give the quantity or volume of earthwork for the cross section of a road either in cutting or in banking. Now, let us see the cross section of a road of a canal, that is the earthwork in canals. As we have seen just now, the cross section of a road in cutting or in banking. Now, let us see about the canal sections. There are three cases for canal sections. Case 1 is earthwork fully in excavation. Case 2, earthwork excavation partly in cutting and partly in embankment. And third case for the earthwork in canals is earthwork fully in embankment. Now, let us discuss about these three cases each one by one. In this visual, we can see the cross section of a canal fully in excavation. Just now we have seen what is this excavation. Excavation is nothing but the cutting portion, the cross section of a canal fully in cutting. When you say that the canal is in excavation, that is when the ground level, this is the ground level and here this is the bed level of the canal. When the bed level of the canal is completely below the ground level, then you will say that the section is completely in excavation. That is, the canal section is completely in excavation. If you take that, if B is the breadth of the canal in cutting and d is the depth of the canal in excavation or cutting, and n is to 1 are the side slopes. Then how to estimate or calculate the quantity of earthwork for the cross section of a canal in excavation? Let us see now. The quantity of earthwork is calculated on the same principle of a road estimate. That is, just now we have seen how to calculate the cross section earthwork for a cross section of a road both in cutting and in banking. Similarly, the cross section of a canal is also a trapezium. So, the quantity of earthwork in excavation is nothing but the sectional area multiplied by the length. The sectional area of a canal is BD plus n into d square multiplied by the length of the section, where B is the width of the canal, D is the depth of the canal, and n is to 1 are the side slopes. D is the depth of the canal. This is how we calculate the quantity of earthwork in when the cross section of a canal is completely in excavation or completely in cutting. Now, let us see the second case for the earthwork in canals. Earthwork excavation partly in cutting and partly in embankment. Here this visual shows the cross section of a canal partly in excavation. This is the excavated portion, and partly in banking. These are the banks on either side of the excavation. If suppose d is the small d is the depth of the canal in excavation and small h is the height or height of the banks above the ground level, and B1 and B2 are the top widths of the banks, N1 is to 1 is the inner slopes of the banks, N2 is to 1 are the outer slopes of the banks, and N is to 1 is the side slopes of the canal in cutting. So, how do we calculate the quantity of earthwork when the cross section of a canal is partly in cutting and partly in embankment? That is, we have to calculate the sectional area of the cross section of a canal partly in excavation, that is this portion, plus the sectional area of the canal partly in embankments. After calculating the sectional areas multiplied by the length of the sections will give the quantity of earthwork that is required when the cross section of a canal is partly in cutting and partly in embankment. The height of bank, that is capital H, from the bed of the canal is generally same throughout. That is, the total height from the bed of the canal to the top of the banks is capital H. It is denoted as capital H. It is considered to be same throughout. The height of the bank H above the ground level is, it may be found as follows. That is, the height of a bank is nothing but the total height from the bed of the canal to the top width of the canal minus the depth of the canal in excavation. The side slope of excavation n is to 1 and inner side slopes of banks n1 is to 1 are given in such a manner that in due course both will attain the same slopes. That is, the side slopes n, n1 and n2 may be same or different. So, the slopes we have seen it, that is n is the inner slopes of the earthwork excavation partly in excavation, and n1 and n2 are the slopes for the banks outer slopes as well as the inner slopes. There may be same